Very good morning, my dear friends. A hearty welcome to my YouTube channel, Mechanical Engineering Lecture Series, and myself, Dr.M.H.Annaiah, Vice Principal at Saptagiri College of Engineering, Bangalore, and a former Professor of Mechanical Engineering, M.S. Ramaiah Institute of Technology, Bangalore. Friends, today I have come with a new chapter, that is the projection of a plane surface or projection of a thin surface or a lamina. Or here friends, when I say it is the projection of a lamina, basically you should know what a lamina is. A lamina could be a thin surface which has got only two lateral dimensions, and the thickness of the lamina is totally negligible. You can say it is just having a line thickness. Now, the laminae are designated as triangular lamina, circular lamina, pentagonal lamina, rectangular lamina, and so on and so forth, depending on the number of sides of the lamina. For example, friends, if you take this is a pentagonal plate having 5 sides A, B, B, C, C, D, D, E, and has got 5 corners. Here this lamina has got 5 corners and 5 sides, and the thickness of this thickness of the lamina is negligible compared to its lateral dimensions. Similarly, you have a triangular lamina ABC. So, whenever I say it is a triangular lamina, it is understood this is an equilateral triangular lamina wherein you have got 3 edges and 3 corners. Again, if you take the example of a square lamina ABCD, all the 4 sides are equal, and this has got 4 sides AB, BC, CD and DA, 4 corners are there. Friends, before I get into the actual problem, let me make the concept of this lamina very clear. Friends, you all know very well from the projection of points chapter that in this projection, first angle projection, you have the vertical plane VP, the horizontal plane is that floor on which I am standing, and the wall to your right side, which is at 90 degrees to the VP, is called the right profile plane, and similarly on the left side of you all there is a wall which is at 90 degrees to VP, that is called the left profile plane. Now, in this particular chapter, the projection of laminae or a plane surface, if you are able to understand the concept behind it, the initial positioning of the object and all such things, it becomes so easy and you will be able to work out any problem if you capture some important points I just mentioned in today's class. Friends, let me take the simplest example of a triangular lamina. Friends, you see here, it is a triangular plate which has got negligible thickness, and it has got say 3 sides. 3 sides are there, AB, BC and CA. Friends, there are some very important points to be remembered in this chapter, namely, the most important is the positioning of the object, that is the lamina. Friends, if you see this triangular lamina, if you hold this triangular lamina parallel to this HP, anywhere parallel to HP, and if you want to get the projections, that if you look from the top, you get an equilateral triangle. So, you can generalize whenever any lamina is held on HP or placed on HP or held parallel to HP, you will be able to see the true shape and size of the lamina in the top view, whereas in the front view, when you all observe, this is going to be a line. Whatever may be the orientation, you can see the front view is going to be a line. Friends, you know very well, the vertical plane and the horizontal plane are normal to each other, means perpendicular to each other, and whenever the lamina is placed on HP on its surface, you are going to get the front view of the lamina or laminae, whatever it may be, as a line on the XY line. Similarly, if you have a triangular lamina, whatever with the lamina held parallel to the wall or held on the wall. When I say wall, it is the vertical plane. Friends, you will be able to see the front view of the lamina in its true form, true size. Whereas when you look from the top, the shadow of this falls on XY, and XY is the line of intersection of HP and VP. So, to combine these two results, I will say again, whenever a lamina is held on HP or held parallel to HP, the top view is going to be the true length and true size of the lamina, whereas when it is held parallel to the VP or on VP like this, on VP, you will be able to get the front view, the true shape of that, and in the top view you get a line on XY. Friends, now you can also have one more position of the lamina. When the lamina is held like this, say in this position, the lamina is held perpendicular to HP and perpendicular to VP. So, whenever it is held like that, you will be able to see in the front view a vertical line, in the top view a horizontal line, and when you look from the end, from the left side of view, you will see the image of this falling on the right wall. So, you can say whenever the lamina is held perpendicular to both HP and VP, the front view is a line, the top view is a line, and in the end view you are going to get the true shape and size of the lamina. Suppose if you look from this side, from your left, the shadow of this falls on the right profile plane, and whatever the view you get that, there on that plane is called the left end view or left profile view or left side view. Similarly, if you are come and stand here and observe this image or this lamina, the shadow of this falls on the left side wall, that is the left profile plane, and you can generalize the left hand view is obtained on the right profile plane and right hand view is obtained on the left profile plane. Friends, now let us come to the actual problem, and in all these lamina, whether it is a triangular lamina, pentagonal lamina, whatever it may be, whenever you place this lamina on HP or on VP, generally we are going to keep one of the edge of the lamina normal to VP. Suppose if you are placing on the wall VP, you have to place the object like this such that the side AB is normal to the XY line or normal to HP. Suppose if you are placing on HP, the side AB should be perpendicular. Suppose if it has to rest on a corner, the corner C should come to left and this side will come to right. Again, that is going to be vertical. So, keeping all these points in mind, let us start with a simple problem on the lamina, the triangular lamina. Friends, remember once again, whenever I say a triangular lamina or a pentagonal lamina, I mean that all these are regular laminae, means all the sides will have the same dimension and all the interior angles will be same. When I say a triangular lamina, it is always an equilateral triangular lamina unless otherwise specified. Friends, after knowing little information, after getting some information about this lamina, let us start with a simple example of a triangular lamina. Friends, the question runs like this: a triangular lamina of side 30 mm rests on one of its sides on HP, one of its sides or edges, that AB, BC, etc. on HP, such that the surface of the lamina is inclined at 40 degrees to HP. Draw its projection. So, let us see what is all the data given. So, in the question he says, we have a triangular lamina. The side measures 30 mm. So, this is a triangular lamina. I have got A, B, C are the three corners. AB is one side of the lamina, BC second side, CA third side. So, there are three corners A, B and C, three sides AB, BC and CA. So, here he says resting on one of its sides on HP. The moment you see that on resting on HP, the initial positioning of the object is very important. because if you go wrong in the first step, other two steps which you are going to have, generally three steps will be there, the full problem goes wrong. So you have to be very careful in initially placing the object. So I will just remind you again, friends, whenever you find a word like this, rests on HP, simply place that lamina on HP or on the ground such that one of the sides of that lamina is perpendicular to this wall VP. Obtain its top and front view. So friends, before that, let me write down the data given. We have a triangular lamina here. It is triangular in shape, and say it is, there's got three sides A, B, C, and each side measures 30 mm, 30, 30, 30. Obviously, the interior angle will be 60 degree, 60 degree, 60 degree. Rest on HP on one of the sides, say AB, such that the surface of the lamina is inclined to HP. Surface of the lamina inclination is given by theta, that is says equal to 40 degrees to HP. So he says, he has given that information. Friends, what is the meaning of the surface of the lamina? Friends, first of all, we will start this problem by writing or by marking the XY line and VP and HP. So I commence the problem by marking an XY line, the line of intersection of VP and HP. So I will say VP by HP, it indicates first angle projection. I told you, friend, whenever you find this marking that is resting on HP, place the lamina on the HP or on the ground such that one of the sides, that AB, is perpendicular to VP. Obtain its top view, a triangle ABC of side 30 mm, and the front view. In the front view, you will be able to see this edge. So I am going to write down a triangle here, an equilateral triangle of side given to be 30 mm. So 30 mm side is the size of this triangular lamina, and I will just mark it as ABC. ABC are the three sides, and all these measure 60 each. So if you have any difficulty in the construction, it is very simple. Mark a vertical line AB normal to XY. I will say this is 90 degree, and here mark a line of length 30 mm. Take B as center, 30 millimeter radius. You strike an arc. Similarly, take A as center with the same measurement. Draw another arc. These two arcs intersect at this point C. So ABC will represent the top view of the lamina when it is resting on HP, on its surface. So here, very obviously, you get a line here. So I will mark this line as A dash, B dash, C dash, as we have done in case of the prisms, etc. So it's just a thin surface, you get a line. If it is a square surface, you will get A dash, B dash, C dash, D dash. A pentagonal face, you will get A, B, C, D and E, and so on and so forth. Friends, now this will represent the front view of the lamina, and you can say very well that since this line has got 3 points, this line represents a triangular surface. Likewise, if you have 4 points on that line, or if that line contains 4 points, it represents a square surface or a rectangular surface. And if it has got 5 points on this line A, B, C, D and E, say, that represents very obviously the front view of a pentagonal lamina which is placed on HP. Now friends, this I have placed on HP. The surface of this lamina is in contact with my hand, that is HP. So in the front view, you got a line. So I will mark this line for simplifying the procedure. This length I will mark it as small m. It has got some value, so I will show this length as small m. So it becomes easy to understand. Now friends, the surface of the lamina ABC is a triangular surface that is in contact with the XY line, and hence it is making 0 degree with the ground or HP. But it says it has to make an angle of 40 degrees to HP, 40 degrees to the XY line. So whatever the lamina we have got here, I am going to redraw this line A dash, B dash, C dash of length m anywhere on this line inclined at an angle of 40 degrees. So same measurement you should take. I have just marked here. mark it in the same way. This is A dash, B dash, and this point is C dash. So A dash, B dash, C dash is the front view of the line redrawn at an angle of 40 degrees to HP. So this is given in the question. Friends, you can see here, friends, in this problem, I have to tell you something. So instead of giving this inclination of the lamina with the HP, they can also give you like this. The lamina is resting on HP on one of the sides, such that the corner opposite to that, this corner is at a height of say some 20 mm above HP. So in all such problems on lamina, any lamina for that matter, they can give you this angle of inclination or the height or the locus of that C. Either they can give you this height or they can give you this angle, so it is all the same. So you should be able to get that. I just wrote this only for the purpose of explanation. Friends, now whatever the front view had is redrawn at an angle of 40 degrees to HP. This line indicates that there is a triangular surface ABC which is resting on side AB, and it is making, surface is making an angle so much. Friends, here after getting this, like our solids, there will be a front view, a top view, front view, top view, like that. A set will be there. Now we had the top view, we got the front view. The front view is written here. We should know what that we are going to get here for the corresponding top view. So the procedure is, you follow the procedure, draw a vertical line from there, a horizontal line from here. The point where those two intersect is the point A. Likewise, vertical line from B, a horizontal line from B. Friends, you get the point B. Friends, remember here this length AB is 30, so even this is going to be 30. So whenever any lamina is resting on HP, the edge on which it is resting will have the same length throughout. So this will be 30, this is also going to be 30, and even if you are writing one more view here, that is going to have that AB equal to 30 mm. This is very important. Friends, after getting this, we have got point A and B which measures 30 again. Draw a vertical line from C, a horizontal line from C. Friend, this is going to be your point C. You have got ABC, 3 points. It is a plane surface. Join all these by straight lines. I am joining A to B, B to C, C to A. So friends, what are the similarities and the differences between these two? We will see. Friends, this AB is equal to AB, that is 30, this is also 30, both are 30, whereas the lateral dimension, that is from here to here, is reduced. This reduction depends on the inclination of that. The more it is inclined, for example, for this position, you got some height. So if you keep on raising this corner, these two lateral dimensions keep on decreasing. So they are going to have some measurement, we need not measure that. So this is the corresponding top view when the lamina is inclined at an angle of 40 degrees to HP. So friends, you can observe here, the lamina is resting on AB. That AB or that edge AB is very obviously perpendicular to VP. I told you, if you have got a line here like this, that is perpendicular to VP. If you have a line vertical, perpendicular to HP, and so on. But what does he say in the question? He says, draw the projections when the side on which it rests. It is resting on side AB, which is again normal to VP, but he says it has to be inclined at an angle 30 degrees to VP. So inclination to VP, you know very well, can be seen only in the top view. Friends, I am going to redraw this figure, the top view, on a line which is inclined at an angle of 30 degrees to VP. So I will just write a line here, anywhere on that line, and mark on that AB. So I will just say, I will mark A here, B here. Very obviously it is going to be 30 mm. I will mark it as A and this as B. AB is one side. So friends, that to be shown by dot line. Let us see, do it later. Friends, how to get this? Point C. The point C, remember, it can be got here above this line or it can be marked here. How to get that? It is very simple. You have the corner B, take the measurement BC, you draw an arc here. BC, this measurement, an arc from here, AC is equal to BC, another arc, they meet somewhere here. Friends, join them. This point you get here is going to be your point C, this is ABC. Friends, before I complete the front view, I would like to say some important point to be remembered on this chapter, projection of plane surfaces or projection of laminae. Friends, you can see here you got the front view of the lamina, this line of length M, same length is redrawn here. Friends, if you call this as figure number 1 and this front view as figure number 2, remember in all the laminae this figure is exactly identical to this. What are the dimension you got here? Same dimension. Figure 1 and 2 will have the same dimension. If you mark this top view as figure number 3 and what are the figure you have got here, that figure number 3, they will be same. So 1 and 2 are same, 3 and 4, this is the fourth figure, these two will be just identical. Friends, we have got the initial positioning, we got the surface incline at 40 degrees to HP, we got the side on which it is resting at an angle of 30 degrees to VP as given in the problem. Now finally, we are left with getting the front view of the lamina. Follow the same procedure, you go step by step, you complete corner A, then go to B, then go to C. Just look at the board, I write a vertical line from here, a thin line, the horizontal line from here, the point where those two intersect is this point. I will call this point as A dash. Next, we have got B, vertical line from B, the horizontal line from B, the point where those two intersect is that point B. Finally, C I want, C is here. So, draw a horizontal from C, a vertical from C. So, these two will intersect here. So, we got all the 3 points required. So, this is C. So, we have got AB, this is BC and CA. So, I will join A to B, B to C and C to A. So, this is C dash and this is B dash, because the front view I will mark here. This represents the front view of the lamina and this gives you the top view of the lamina. So, friends, the last figure will give you totally the projections of the lamina, that is the front view represented by A dash, B dash, C dash and the top view, that is ABC. Friends, I hope you were able to follow the small concepts I gave you for the initial positioning of the object, and I am sure you have followed this. If you have followed and if you are happy with the presentation I have made, do subscribe for my channel Mechanical Engineering Lecture Series by Dr. M.H. Annaiah.